So in this problem, we have a wall form which is subjected to a wind load of 20 psf and is prevented from overturning by these diagonal braces spaced 8 feet on center along the length of the wall form as shown in the figure. The connection at the base of the form at point A is equivalent to a hinge. Ignore the weight of the form. The axial force in pounds resisted by the brace is most nearly. So when I think about these problems, and I'll tell you that they are very common on the exam, and it's a type of problem that NCEES wants you to be able to solve for the civil structural engineering exam. Um, I like to think about them in an isometric view, right? So if I was to draw this wall, right, here is the wall kind of in an isometric view. Here's the length of the wall. And then we have at every 8 foot a brace along this wall form, right? And here's this 20 psf load shown in gray. It's acting along the full height of the wall form. And you have these braces every 8 feet. So what I like to do is figure out, okay, if we were to just take a section at the brace, what would the load be on the length of the wall? To figure that out, we'd have to say, okay, well, this 20 psf force is acting over the full height of the wall, and the tributary width that it's acting is every 8 feet, right? So the load W would be equal to, let's just write this out here, W is equal to 20 pounds per foot squared times the tributary width of 8 feet is equal to 160 PLF. Okay, so now let's draw a free body diagram knowing that we have this force acting along the length of the wall. So to do that, what I'm just going to draw here, this is our 160 PLF. Here's our wall. Here's point A. And then we have a force in the brace, which is acting at a 45-degree angle. Okay, and we'll call that force F. And we'll just label this 160 pounds per foot. Okay, so F has two components, right? It has a horizontal component, Fx, and it has a vertical component, Fy. Okay, so Fy does not cause a moment about point A, but Fx does cause a moment about point A, right? Because it's tending to rotate, it's going to push the form back against the force of the wind, right? So that's in a counterclockwise direction, and it's acting at a height of 10 feet above point A, right? So if we want to figure out what this unknown force Fx is, what we can do is we can just sum the moments about point A. And that's going to be equal to 0, and it's going to be equal to our 160 PLF that's acting over the full height of 16 feet. And then the distance away from A that it acts, it's going to act at the height divided by 2, right? So 16 feet divided by 2 is going to act at that centroid of that wall is equal to 8 feet. And then we have to subtract our Fx force. And again, that Fx is acting at a height of 10 feet from A minus Fx times 10. So quite simply, we can take the 10Fx over to the other side. And that's going to be equal to 20,480. So then if we want to get what Fx is equal to, that's going to be equal to 2,048 pounds. And now we have a very simple trig problem, right? Because we know that we have a right triangle here. It's a 45-degree triangle, right? And we know when we have a 45-degree triangle, the two sides are n, the hypotenuse is n root 2, right? So if 2048 is equal to this horizontal n component, all we have to do is take our 2048, multiply that by square root of 2, f is equal to 2,896 pounds, and that is going to be most nearly choice C. And there we go.